But first, a few words about me. I'm Tomasz Konieczny. I'm a test architect and quality consultant. And in general, I'm interested in very different aspects of quality, but mainly test automation, architecture, and infrastructure. And today's presentation will be related to all of these partially. I also speak at conferences quite a lot, and currently I work as QA lead at TestKube, so I'll be able to tell you a bit more about how this testing tool is actually tested. But first, let's start with something more generic. Let's start with one of the very common business requirements that can make modern software development more challenging and complex. And I mean fast delivery of high quality software. I mean, it's difficult, at least from the technical perspective, because it's like trying to combine two completely opposite things. How to do something fast and how to keep it high quality at the same time. But the reality is that it's often a prerequisite for a successful product, so we need to deliver it somehow. Because we need to deliver something that will fit user expectations, that can be pretty high nowadays, and we need to do it fast, because otherwise competitors will do it first. So from quality perspective, this goal can be simplified to just fast and complete quality feedback. Because if we will have it, we will then be able to deliver the rest. And we'll be trying to achieve it in every single possible way. We'll be trying to shorten quality feedback loop to get this feedback as fast as possible whenever we need it. We'll be doing it in very different ways, by shifting left, trying to test earlier in the development process, even before any code is implemented, just to get this feedback faster and to be able to have better picture of quality state. But the second part is automation. I mean, automating almost everything that makes sense, just to make repetitive actions faster, more predictable, to get this feedback earlier this way. We'll be trying to achieve continuous feedback, so anytime, whenever we'll need it, we'll have the full picture of how the quality state looks like. And then we'll be trying to make this feedback complete. So very different test types on very different levels, very different quality tools that will need to be introduced just to get this feedback, to make this feedback complete. But then there is one more problem that will appear. I mean, what about additional complexity of all of these different tools that need to be introduced? All of these tests need to be implemented and then maintained, and it can increase the complexity. And then what about infrastructure and pipelines? I mean, that's something that's just a prerequisite, just to run these tests. But if we will have very different testing tools, it may be even more complex than the actual test implementation. And that should be just a prerequisite. We just need it to run these tests. And today I will show you one of the possible ways of doing it, or simplifying it, with the combination of Kubernetes and TestKube project. What is TestKube? It's an open source test orchestration and execution framework for Kubernetes. So to simplify, it's just basically an abstraction over Kubernetes that's more focused on test execution, and it can unify it in various ways. So the first thing is that it provides the set of pre-configured executors. So these are the abstractions for various test runners like Postman, K8s, Cypress, Playwright, etc. There is quite a lot of these. And also one more that's pretty special, custom container executor. Because this one allows you to use any Docker image you may need to run the test for your specific testing tool and still use all of the abstraction that TestKube provides. And the second part is this test-specific abstraction. So basically, TestKube extends the types that are available by default for Kubernetes with the ones focused specifically on test management and execution. So it may be test, so that's the most simple one. That's the simplest unit that can be executed with TestKube. It may be a single test, it may be a complete project, like for example, Cypress or Playwright. Then there's a test suite, so it's the combination of different tests that you may want to execute as a whole. Executor, so that's an abstraction over different test runners. You may adjust one of the existing ones. You can define completely custom this way. Test source, abstraction over Git repository. So it's pretty common thing to have very different tests in the repository. So with test source, it's possible to abstract away the way of getting this test from the repository. So authentication and things like that. test triggers, webhooks. I will also show these later. But let's start with setting up TestKube first. And what's needed, some prerequisites. You definitely need to have kubectl and Helm installed. And if you already use Kubernetes, you'll probably have both of these. And also you need some cluster. It's possible to reuse something already used in the project. So if you have some test cluster, TestKube supports namespace installation, so it's probably possible to use it. If you don't have it, we can just try to run locally with Kind or Minikube, whichever you prefer. Then you need to have the TestKube CLI installed. It's just a kubectl plugin that makes things simpler and allow you to run the test, manage the execution, etc. And also the TestKube cluster side components need to be installed on the cluster side. Let's start with creating the cluster first, so it will be easier to go through these things if you want to try it. So in this case, I used Kind. Based on my experience, it's just more predictable and stable than Minikube. So Kind create cluster and optional name. Let's name it TestKube Kind cluster. It's created, the context is set, everything is ready. We have our cluster ready to be used. And then we need to install TestKube cluster side components. I will do it with TestKube CLI. I skipped the installation because it's just a single binary. So there is a command like TestKube install that allow you to install TestKube cluster side components. Namespace is optional. By default, it's TestKube. If you will skip it. And just a simple question about context, just to confirm it's set correctly. And then everything is installed. Alternatively, you can also use Helm directly here. It's just an abstraction over Helm. So if you prefer this way, it's also possible to do it. Charts are also available in the repository. Then let's check what's installed there. So kubectl get deployments, namespace TestKube, and we have a few of them. The most important one is TestKube API server. So that's basically the work orchestrator that handles the executions, triggers the tests, gathers the results, processes them, etc. And the second one that's also important here is TestKube operator control manager. So this one watches TestKube custom resources on the cluster side and then can trigger actions based on this. I will show you some examples later. And it also communicates with API server. So it's ready. Let's finally run some tests. And the first example will be the K6 test. If you haven't used this tool before, it's just a great performance testing tool. And in this case, all of the examples I will show you are in the TestKube repository. Everything is open source. You can check these examples also there. And let's run this test from the repository. And to do it, we first need to create it. This time we'll use CLI. And TestKube create command allow you to create any of resource types supported by TestKube. So in this case, it's TestKube create test, because we'll be creating test here. And the name is mandatory. Let's name it K6 example. Type is also mandatory. It's the executor that should be used to execute this test. So in this case, we'll use K6 script, which is the pre-built executor. It's released along with TestKube with some predefined configs. So type K6 script, and then instructions how to get this test. So test content type Git, we'll get this test from the Git repository, and then instructions how to do it. So in this case, it's a public repo, so just git URI, that's the main TestKube repo, git branch, let's keep it main, and git path, so that's the path for specific file that should be executed. In this case, it's K6 test, so just a single JS file. In the directory, test K6, executor test, etc., just a single JS file. So let's create it. Test has been created. And now we can check what's there. And TestKube get command allow you to show details about specific resource, like in this case, test, and just the test name, K6 example. And we have everything that we just created with some additional labels that will be also useful later. Let's finally run it. So TestKube run command allow you to run any type of resource. It may be test, it may be test suite. In this case, it's just a test, and K6 example, the name of this test. -f is optional. It's just a follow option, so you will get the output directly after triggering it. Without it, it will just trigger the test without getting the results. So the test has been executed. The execution is successful. And what else is possible with this CLI? So in general, it's possible to manage any kind of TestKube resources, creating, editing, and deleting them. It may be test or test suite, it may be test source, it may be executor, also triggers, webhooks, and other more advanced things. It allows you to run, watch, and abort executions for both the test and test suite. It's possible to manage artifacts. So for example, if your test produces artifacts, like for example, Cypress will generate screenshots in case of failure, it will also be possible to download these with CLI. And it also allows you to manage the TestKube. So that's how we installed it in the first place with TestKube install command. There's also TestKube upgrade, again, an abstraction over Helm just to make things simpler. But the most powerful thing is not just using CLI, it's about CRDs. And as I mentioned, TestKube extends the default types available in Kubernetes with the ones focused specifically on test execution. So let's start with another example. This time it will be a Postman collection, again in the same repository. And let's create it with the CRD first. So there is an additional type, kind test. And then the definitions of the test. Metadata name is again mandatory, so let's name it example Postman test. Namespace TestKube, you can put it here, you can put it on kubectl apply later if you have multi-namespace installation, and if you would want to run it in the different namespaces. And then the spec, so instructions how to execute this specific test. Type, again, it's mandatory, that's the executor that should be used to run this test, and again we will use the default one. So that's Postman collection in this case. And then content, so instructions how to get this test and how to execute it in general. So content type Git, because we'll use Git repository here. And repository settings, URI, that's repo URI, a branch, main, and path. In this case, it's just a JSON collection from Postman and the repository, so test, Postman, executor, test, etc. And that's all we need to run this test. We can apply it as we would do with any other Kubernetes resource. So kubectl apply -f, name of this YAML file. Let's assume it's Postman test YAML. And it's applied, we can run it with CLI in the same way as we ran the previous one. So TestKube run test, and example Postman test, that's the test name. The second one may be a bit more complex. I will show you what's also possible here. So this time a Cypress project. It's again in the repository, but it won't be a single file. It will be the complete Cypress project this time. And again, kind test, so that's the test type that's defined here. Metadata name, let's name it Cypress test example. Namespace, again, TestKube. And labels, these are optional, but are pretty useful while scheduling tests. I will show you some examples later. And then the specs, so instructions how to run it. Type, it's again the predefined executor for Cypress, so this time Cypress test. Content, type Git repository credentials, and the thing that's important here is the path. So this time it won't be a single file, it will be the complete Cypress project. So in this repository we have very different tests that are actually used for testing TestKube. For example, if you will go to the test Cypress directory, executor tests, you will find multiple different projects for Cypress with different Cypress versions. In this case, we'll just use the one for Cypress 12. And these tests are quite specific because we are using them to actually test TestKube. And we are validating if they can be executed successfully. We also set various configuration options like ends, arcs, etc. And this test will only pass if these things are set. So if end variables are set correctly. So that's something additional that we test while executing these, while testing how these executors work. And these things can be set with execution request. So we have variables here, like Cypress custom env set to Cypress custom env value, type basic because it's just the standard env variable that will be created for this pod while it's being created. But it's possible to also use secret refs here. I mean, it's pretty configurable here. And also arcs, so these are just passed to Cypress binary in this case, so another env set this way, and also some configuration options, so config video false, just something Cypress specific, not to record videos. But with execution requests, you can customize almost everything. I mean, it's even possible to override the job template. So you can set timeouts here, you can set resource requests, limits, etc. All of these things can be customized here on the test level. And we have this definition. We can apply it with kubectl apply -f Cypress test YAML. We can run it. So testkube run test, Cypress test example, and it will be run. We can version it in the repository, and we can have the definition of how to execute this test along with this specific test. So we can put everything in the repository and version specific instructions how to run it. But writing these definitions from scratch may not be that easy initially. So that's why testkube CLI allow you to generate these definitions with CRD-only argument. So in this case, it's just the first example for K6. I just appended CRD-only, and I got this definition. I can then put it into the repository and create the test based on this. So it makes things simpler to start. Sometimes it's just easier to use CLI initially. But just running the test using pre-default executors, it's not enough. And as I mentioned, the executor that's the most powerful is custom container executor, because it allows you to run any Docker image that you may need here. So let's assume we need a very specific Cypress version. Let's choose, for example, 12.7. And let's create the custom executor that will fit this specific version. So it's again type kind executor. And then metadata name, this one is again mandatory. Let's name it container executor Cypress 12.7. Namespace testkube and spec, so instructions how to execute these things, these tests, how this executor should work. So we have a spec image here. It's a Docker image that will be used here. It's just official Cypress image, an included version with everything that's needed, browsers, etc. with this specific version 12.7. Then executor type container, because it will be the container executor. Alternatively, it's also possible to set job executor here. And also then we have types. So these are the types that will then be available on the test side. So we are defining the custom type here. Let's name it container executor Cypress 12.7/test. And that's the type we can then use on the test side. So if we would like to run the previous Cypress test with this specific executor, all we need to do is to update spec type on the test level and replace it with the one that we just created. And that's all. We can run this test, and it will use this specific executor that we just defined. And this one is, this definition is simplified on purpose, but it can be pretty custom. I mean, it's possible to override commands, args here. It's possible to set default resource request limits, etc. Everything can be customized here. It's possible to even override the job template completely. So almost everything is possible here with these custom container executors. And defining new ones is also pretty easy. But then you will rarely have just a single test or a single tool. You would often want to run multiple tests in some specific way. And that's what's possible with test suites. So basically, test suites allow you to group tests and execute them in a very specific way. And again, the next type, kind test suite. And let's run these three tests that we just created. So K6 example Postman test, and Cypress test example. And let's name it example test suite. So metadata name. Spec are the instructions how to run these tests. And we have something like steps here. We have two different steps that start with stop on failure, true or false, depending on how you want to proceed with execution after something fails. So by default, let's stop on failure true. It will just stop the execution of further steps if one of them fails. And in the first step, there is execute keyword with a single test. It's K6 example. In the second one, there are two different tests in the execute. So in the first case, it's just a single test that will be executed. And in the second one, both of these tests will be run in parallel. So it's possible to control the whole execution flow here, to execute tests sequentially, to execute them in parallel, whatever is needed. So again, it can be applied with kubectl apply and run this time with testkube run test suite, because we'll be running test suite in this case. But test suite can also be parameterized. So if you need to override any specific settings from the test, you can do it on the test suite level. And in this case, let's assume we have some K6 tests we would like to run in parallel to build the bigger set of performance tests. And we can customize them with execution requests. Like, for example, we would like to set different arcs for different virtual users. So we can do it, and the first one will be executed with 100 virtual users, the second with 200. We can build the whole performance test suites this way and run it in parallel. Again, kubectl apply to apply it, and then we can run this test suite. But what about pipelines? How to even run these tests as part of existing pipelines, or how to build the custom ones? It's possible to do it in very different ways. I mean, it's possible to trigger tests manually with CLI, for example. It's possible to cron trigger them because it's still quite useful to run some of the tests, like, for example, every few hours. It's sometimes useful. It's possible to also integrate them with existing pipelines. Like, for example, there is GitHub Action, there are some other plugins for different tools. But the way that's probably the most powerful is to use cluster events and execute everything on the cluster side. And that's possible with test triggers. They basically allow you to run the tests on Kubernetes cluster events. So let's create some trigger, and let's assume we would like to run this K6 example test, which is created in the TestKube namespace. When something happens in completely different namespace, let's assume it's just deployment of Nginx in the default namespace. So kind test trigger, that's the type for triggers. And metadata name, let's make it as descriptive as possible. Trigger K6 example on Nginx creation. Namespace TestKube, that's where the TestKube is installed. And spec, what should happen and when. So first, resource deployment, because that's the resource type that will trigger some action. And which one? The one defined with a resource selector. So in this case, it's name Nginx and namespace default. So it's just the deployment of Nginx in default namespace. Event created, so if it will be created, it will trigger some action. And which action? The one described with execution test and action run. So it will run the test defined by test selector. So in this case, it's name K6 example and namespace TestKube. So if we'll deploy Nginx in default namespace, it will trigger this K6 example test. Let's apply it, kubectl apply -f example trigger YAML. It's applied, and then let's try to deploy this Nginx. So kubectl create deployment Nginx, image Nginx. The deployment has been created, and that's the exact moment when this test has been triggered. And this one is pretty simple because it's just mapping of the name to the name, but it's possible to build way more complicated triggers here. And in this case, it's just creation of deployment. But if you would set, for example, update of the deployment, it's the easiest way to run tests when something changes on the cluster side. But mapping name to name is just the simplest one. So in this case, it was deployment named Nginx, and it triggered the test named K6 example. It's possible to map names to labels, like, for example, change of specific resource can result in multiple tests being triggered based on labels. So, for example, any test sharing specific label will be run here, or labels to name. So the change of any resource with specific label can trigger the run of test or even test suite by name or by label. So it's possible to build pretty complex workflows here just based on cluster state, which is pretty useful while testing things, because simple deployment can result of specific tests being run there. But that's still not all. I mean, being able to create tests isn't enough, and usually we'll be trying to match the ways how to execute these tests with specific definitions and combine it with specific projects. So, for example, let's assume we have some tests in the repository, like, for example, K6 tests in specific directory. We'll have multiple of these. We can put another directory there, let's name it CRD, and it can contain everything that's needed to run these tests. It may be test, it may be test suite definition, it may be executor definition, or triggers or webhooks. I mean, we can put everything there, and we will version instructions how to run these tests, how to set up everything along with the tests in the repository, and everything can still be executed fully on-prem inside your cluster. you won't even need any external components there just to run these tests to get this feedback, to get these results. And that's what we also do in the TestKube project internally. I mean, we need to test everything that we use, like, for example, executors. We have various different tools that are supported. We have various different versions. So if you will go to the test directory in the TestKube main repo, it's open source, so you can do it easily. You will find very different directories for different testing tools. So Artillery, Cypress, Ginkgo, Gradle, whatever. There's a lot of these. And in every single directory, you will find various definitions for these, for the tests, test suites, triggers, webhooks, etc. Everything is there. And that's also the best place if you're looking for more complex examples. I mean, we are also testing edge cases there. So it's not like just the basic flow that's needed to execute the test, but also more complex ones with modifications of job template, for example, resource request limits, timeouts, all of these things that may be needed to run it in a scalable way. Everything is in the repository. And if you will be looking for more examples, I really recommend you to check the docs because they are surprisingly up to date. We are just using, again, the same examples that we use for testing TestKube. So if they pass, that's the moment where they can be released. And also GitHub, that's the main repo here and the test directory where all of these more interesting examples are. And they can be tricky somehow, sometimes, because we are using very different tools there with very different strange settings. I mean, we are often trying to rebuild things suggested by users, for example, that they try to use. So a lot of edge cases there that you may find interesting. And that would be all. Thanks. And if you have any questions,